Algebra 1, Lesson 71, we are doing a quick lesson on making and analyzing scatter plots, especially looking at those trend lines so we can predict the future. Now, a scatter plot is a graph that relates two sets of data with plotted ordered pairs, and we can create a trend line to best fit those points, showing the relationship between the two sets of data. And this is typically a linear relationship. That's the type we're doing today. And we can also look at the correlation of the points by looking at the measure of the strength and direction between the data sets. So try one by hand. We can look at this set of data. We have x's and y's that we are going to plot, and I'm actually going to use my coordinate grid to plot them. The y's will be going by 2's, and the x's will be going, that should have been 12. There we go. And the x's will just go by 1. Just mainly because I don't have enough room on this grid. So 1 goes to 4, 2 goes to 10, 3 goes to 12, 4 goes to 18, and 5 goes all the way up here to 23. And now what we need to do, this looks like a pretty strong correlation because all the points are in a line pretty close together. Now we need to draw a trend line, which means I want to go through as many points as possible with a completely straight line and splitting the difference between the ones that wouldn't fit here. So I'm going to draw my line about like that. Okay? It splits the difference between a lot of them. I have some on one side, some on the other, and trying to go through as many as possible. Now, when I find the equation for this trend line, I want to make sure to use points that are exactly on the line, not scatter plot points necessarily, but points that are actually on the line. So, for example, I would use a point right here at 3, 20. That's a pretty good one. 3, 20. Here, let me get my pen again. All right, 3, 20 right here. That's a pretty good point. And then I might say another good point was right here at 4, or sorry, not at 20, 3, let's see, 14. There we go. 14 because my 4 was at 18. So it looks like I can find my slope by doing y2 minus y1, so 18 minus 14 over x2 minus x1, so 4 minus 3, which means I have a slope of 4. Now, depending on your trend line, you might have a slope that's about 4, maybe 5, maybe even up to 6. Regardless, it's going to be somewhere in that range. It just depends on how you drew your trend line. Okay, now I need to put it into an equation, so I can use one of my points. So we'll say y minus y1, so let's say that's y minus 18 equals my m, 4, times x minus 4. So we get y minus 18 is equal to 4x minus 16. I add 18 to each side and see that we have y equals 4x plus 2. Okay, that would be about a decent y-intercept. It looks like on my line it goes through the origin, but using my points I see that if I had a slope of 4 with those points, it would go through at 2. Now your y-intercept might be at the origin, maybe -2, but it needs to be somewhere in that range. And with this we can make a prediction. We can say, well, what would it be if x equals 6? So we would plug in 6 for x and see that x would be, with my trend line, at about 26, or 10, or 50. We could put in any x and predict what it might be. It might not be that exactly in reality, but we can predict what it could be. Now, we could also do this with a calculator, and I'm going to do a very short tutorial on how to do this. So we have some scores here, average homework scores and average test scores. So I have plotted these in my graphing calculator that I will pull up. And let me just move this so you can see as much as possible. So, and to do that, remember, I'm going to go to Stat and Edit, and I have all of my data in here, the x's in L1, or the homework scores in L1, and the test scores in L2. Now, when I want to plot these statistics, I'm going to go to second y equals, which gives me this stat plot. And we have it on. We need to make sure it's on. And we want to make sure it's on Scatterplot. Then we check, is my X list in L1? Yes, it is. Y list in L2? Yes. If, though, one of these were not correct, we could always go second stat and choose the one I wanted. Okay, maybe yours is in L3 or L4. And then we can go to zoom and press number 9, which is zoom stat, meaning I'm going to zoom in on the statistics. And this is my scatter plot. Not as strong as the last one, still a positive linear correlation, but kind of medium strength, a little bit weaker. Now I can also find a line of best fit for this, and our calculator can do quite a good job at this. So I'm going to go back to stat, and instead of editing my list, I'm going to find an equation for the list. So number 4, linear regression. And I check again, is my X list L1? Yes, it is. Y list L2? Yes. Frequency list, don't worry about that, but we do want to know where are we going to store the regression equation. And to figure out where to put that one, we want it in Y1, which we're going to find that by going to vars, over to yvars, number 1 function, and we choose Y1. And then we calculate. And this gives us an equation in the form of y equals ax plus b, just like y equals mx plus b, where a is 0.558 and b is 39.79. Now you could write that in and plug it into y equals yourself, but if you stored the equation correctly, it should already be in your equation. And we would have that 0.55, it's really long decimal. Okay, it keeps going, x plus that 39.8. And we graph, and we see this line that cuts through all of our dots. Especially this one, it's quite an outlier here. Maybe not technically, but it looks pretty far away. Now, maybe we want to figure out, well, what if we had an average homework score of like 99? Well, I need to expand my window so that I can trace that and figure out where it would be. So I'm going to go to Window and change my X max to be, let's say, 100, because we could have an average score of 100. We graph again and we see it's just expanded a little bit. And now I can trace, but not like my normal trace, because trace just will go on your scatter plots. Now I'm going to do second trace. And instead of doing intersect like we've done in the past, I'm going to do number 1 value, which means I'm going to plug in an X value that I want, well, in this case, 99. And I press enter to figure out, well, supposedly, with my trend line, I would have an average test score of about 95. That's a pretty good guess. So this is how we would do it on a calculator. Okay. Just quickly, remember, by hand or by a calculator, you can figure out some predictions with these trend lines. Now, a correlation is something else we can get from our scatter plots. It's the measure of the strength and direction, like we said in our vocab. And when points are really close together, we call that a strong correlation. When they're all over the place, it's weak. So, for example, this is a strong positive correlation because it has a positive slope and the points are relatively close together. Whereas something like this one would be a negative strong correlation. And this one would be no correlation because it's not going up, it's not going down, it's just all over the place. So there's no true theme we can get from it. Here's some other examples. For the first one, this would be a very strong positive correlation. This would be either a weak positive correlation or no correlation. It's just barely going up. No correlation here. This would be a pretty strong pretty strong negative correlation. A little bit weaker negative correlation, and lastly, no correlation. So to just go over a couple different examples here, we can figure out with words what these might be. So time spent exercising and calories burned, well, I would imagine this is a positive correlation because as I increase my exercising, my calories burned also goes up. That kind of looks like graph 2. Number of dishes washed and number of ounces detergent remaining. Well, as I increase the number of dishes, the amount of detergent left goes down. So I would say that's like graph 1. That is correlated. And the population of a country and number of states in the country, that really doesn't have any relationship with each other. So we would say that's graph number 3 or no correlation. Okay, here are some other examples that you can look through and try on your own. Okay, especially some of these, I would encourage you to do it by hand and then check your work on a calculator to see, okay, how did we do as far as our predictions? Okay, and same with this one. Well, I hope this is helpful for your homework and for studying.